I'm starting to record and I'm starting to share. So you should see there's the rules. And all right, so let's see, let's make this just a little smaller. There we go. All right, so what we're going to do is we're going to be filling in these blanks here. Looks like I have a, come on.
Whether you can also
There.
project what you're doing on the computer onto like
Yeah,
there, so I can see it.
is that,
Just grab my laptop.
yeah, that'll be fine.
Ew.
All right, so first, any uncombined element. So if you just have one element and you don't have any pluses or minuses, then its oxidation number is 0. If you have a monatomic ion, then its oxidation number is just its charge. So that takes care of the first 9 there. So the first 7 of them. So the first 7 of them, if you don't see a plus or a minus, it's 0. Do you understand the first 7 are composed of just one element?
Yeah.
Okay, and if you see a plus or a minus, then it's an ion, and then the charge is the oxidation number to its charge, because those are what are called monatomic ions.
So it's either 0 or it's charge.
Yeah. So it's 0, -1, 0, +1, 0, 0, +3.
Bless you.
Ah. Why did it do that?
Oh, look at that. Mr. Ryan, you're so smart. Putting in all those answers.
Now, when you come to, okay, we have, a compound. 8 is a compound, 9 is a polyatomic ion, 10's a compound, 11's a polyatomic ion, 12's a compound. Okay, so let's go down and look at our rules here. First, oxygen has an oxidation number of -2. Unless it is combined with fluorine, then it's a +2. Or if it's in a peroxide, such as H2O2 or Na2O2, then it's a -1. I'm going to try really hard not to have any of those exceptions on your test. So oxygen for us, oxygen is going to be a -2, and it almost always is. So then hydrogen, number 6, when hydrogen is combined with nonmetals, it's a +1. When it's combined with a metal, it's a -1. Okay, and then 8, the sum of the oxidation numbers in a compound is 0. That is, when you sum the charges, it's going to equal 0. And then if you have a polyatomic ion, the sum of the total charge is going to be equal to the charge of the ion. Now that's a bunch of words. It doesn't mean anything to you till you see me work. Right? Okay, but once I work them, then it'll make some sense. All right, so further down here, this is the answer key to all of them, so you can check your work. Okay, now this is the how-to. I put this together, so I hope this is worded okay. Okay, determine what you know from the rules. Okay, so let's go back. This is number 1. Just go back to number 8 here. What do we know from the rules? We know that oxygen's a -2. Correct?
Correct.
And we know that hydrogen, when it's combined with nonmetals, is a +1. Okay, so now that one's done then. Okay, questions on number 8.
I have a question. Could you please explain the first 2 rules again?
Yes. Oxidation number of any uncombined element is 0. Uncombined means it's not combined with any other element. So here you have just chlorine. Here you have just sodium. Here, number 5, you have just oxygen. Number 6, you have just nitrogen. So their oxidation numbers are going to be 0. Rule 2, the oxidation number of a monatomic ion is equal to the charge on the ion. So this is a chloride ion. It has a charge of -1. So that's its oxidation number. Sodium is a charge of +1 when it's a sodium ion. So it's +1. Aluminum ion is a +3. Does that work for you?
Does monatomic mean only one type of atom?
It means a single atom.
Okay.
Uncombined means one kind of atom.
Okay.
Slight difference there. Yes,
Number 17. This one's too low.
that's a little bit, you have an answer key.
No, oh, wait. Oh, okay, I think good.
All right, so next I'm going to go through a polyatomic ion. This is nitrate, NO3 minus. So I have it copied further down. So first we're going to do what we're going to divide it. Divide the, number 3, divide the compound or polyatomic ion to its parts with a line. So we're going to divide it down the middle. Okay, now here's the deal. We know oxygen is a 2 minus. So we know it's 2 minus. Okay, now the reason we got to go through this process is nitrogen has 6 different, is it 6 or 4? Let me look real quick. No, 5. Nitrogen has 5 different oxidation states. Now, the reason you need to know oxidation numbers is when you take AP or IB chemistry, you have to do what are called oxidation and reduction reactions. And so the oxidation numbers tell you their state at any time during a reaction. So you got to keep up with what's going on with the electrons. So we're not going to get to oxidation and reduction reactions this year. Normally we do, but this year we're not. But I need to, because somewhere between a third and half of you are going to take more chemistry, I'm going to take the time to show it to you. Second, it's with a little practice, this is easy stuff, and so it's an easy way for you to get a good grade. All right, so what we're doing is we figure out what we know and use the rules to figure out the unknown, and the unknown is nitrogen. So we go 2 times 3 gives us 6. Now what that number, that's the total negative, or it's the sum. This is the sum of the negative charges. The sum of the negative charges is 6 minus. Okay, and so according to rule number 9, the oxidation numbers of the sum of the oxidation numbers of all atoms in a polyatomic ion equals the charge of the ion. What is the charge on this ion?
-1.
It's a -1. So that means when I compare my numbers at the top here, that I'm going to have one more minus, then plus. So the other way of saying this plus over here is going to be one smaller than the negative. So it's going to be 5 plus. So when I combine these, they're going to equal -1 because of that right there. Okay? That's real key, because that's really the only thing people miss on this test. Well, let me rephrase it. I do have some students who get to this test and have no idea what we did. But most students that try, put some effort in, the only thing they have trouble with are the polyatomic ions, because it's you've got to get the rules in place. All right. What's that?
Why didn't you do the thing for H2O?
I mean, I can.
But how do you know or do we do it every time?
If you're having trouble, yes. But I just say, I mean, we'll go down to it. We can, because see, the rules say, let me see, here, sorry, it's going the wrong way. The rules say oxygen is at -2 unless it's with fluorine or in a peroxide, okay? Well, we look at this. This is not a peroxide, not fluorine, so we know oxygen is 2-. Rule 6 says hydrogen in most compounds is a +1 unless it's with a metal, okay? Well, it's not with a metal, so it's a +1. So boom, we're done. However, we can go through this split it up process just fine with this. What happened to my, okay, it's not a big deal. Oh, goodness, I hate it when it does this crap to me. Ah, so annoying. Okay. We'll get through it. Oh my goodness, why is that doing that to me? I gotta go through this again. All right, so we split it up. We know that oxygen's 2-. 2 times 1 is 2-. We know from rule 8 that the sum up here must equal 0. So this has got to be 2+. We also know from the rules that hydrogen's 1+ in this case. Okay, so 2 times 1 is 2. 2 divided by 2 is 1. And the sum of these equals 0. So all of our rules, this is a way of verifying you got everything. Okay?
Thank you.
Sure. All right, going back to nitrate, we have 5+ divided by 1. So this nitrogen is a 5+. So we go back up. And I got to do this way. Come on, give me my, goodness, where did it go? All right. Okay. Now the next one is nitrogen dioxide. Okay. So we know that oxygen's a -2. And we just got to figure out what nitrogen is. Now, some of you are good enough right now, you can tell that's a 4+. Some of you have no clue how I got 4+ that easily. Okay, so we'll go down and go through the process. Remember, the sum of the oxidation numbers of all atoms in neutrals, okay, misspelled there. In a neutral compound is 0. So we go down here, here it is. Get my marker, get my pen. What the heck was that? Okay, try this again. Okay, we know that this is 2-. 2 times 2 is 4. Okay, we know by definition or rule, this has got to be 4+. 4+ divided by 1, because there's only one nitrogen, means it's also 4+. And the bottom numbers are oxidation numbers. Okay, so these are my oxidation numbers. Now, not subscripts. So I don't want you to think that these numbers, these are your oxidation numbers. Oh boy, horrible. Okay. Get it, got it?
Yes.
All right. So back, go to chromate. Cr2O7, 2 minus, a net charge is 2 minus. So when I compare my oxidate sums of my oxidation numbers at the top, I'm going to have 2 more minuses than pluses. Okay, so we'll go down here. We put a line between them. We know that oxygen is 2 minus. 2 times 7 is 14. This 2 minus means this is going to be 2 less than 14, which is 12. It's divided by 2, which tells me the Cr in this case has a charge, each chromium ion has a charge of 6 plus. Should I go back up? Oh, gotta do it this way. Okay. Now, periodic table. In group 1, that's these guys. Group 2, group 1, group 2. Group 1 is always going to be +1. Group 2 is going to be +2. And aluminum is going to be +3. Always, always, always. Again, that's in the rules. Okay. That rule 7. In compounds, the elements of groups 1 and 2, as well as aluminum, have oxidation numbers of 1, 2, and 3, respectively. Okay. So, potassium's in group 1. We know it's that. And therefore, by definition, this one's got to be a -1 because you got to have an equal amount of plus and minus. Okay. All right. Now, here's a case where almost all chemical formulas have the positive oxidation number on the left and the negative on the right, but not when it comes to, well, let's put it as, that's a pattern that's usual, but normally, instead of saying it that way, the first one you see is the quote central atom. If there isn't a central atom, then the one that's positive will be on the left. I hope that makes sense.
Yeah.
All right, some of them, it's not a big deal. If you just follow the rules, it's not going to matter whether they're on the right or left. Generally, the general pattern is the one on the left is positive, the one on the right is negative. That's a general pattern. It's not absolute. Okay, so in this case, for ammonia or nitrogen trihydride, which is what this is, we know that the nitrogen is going to be, the hydrogen's +1, because it says by rule, if the oxidation state of hydrogen in most compounds is +1 unless it's combined with a metal. Nitrogen's not a metal, so hydrogen +1. There's 3 of them, means the total positive charge is 3. So the total negative charge must be -3. And there's only 1 nitrogen, so it's got to be a -3. Did you follow the logic, or do I need to diagram it for you?
I followed.
All right, how about y'all? Okay. All right. Next, calcium is always a +2, and hydrogen's always a -1 when it's combined with a metal. Remember, calcium's a metal. Do I need to review that? Rule 6. Oxidation state of hydrogen in most compounds is +1 unless it is combined with a metal, in which case it's a -1. Okay, calcium's a metal. I know we don't think of calcium as a metal. What's that?
You're a -1, Mr. Ryan.
Oh, well, thank you.
You're welcome. That was a good one.
That was just, is that all? I figured it'd be a much bigger minus than that.
Yeah, it's a minus.
All right. So next we have sulfate. Do I need to go further with this, or are you guys ready to?
We're good, you can stop talking.
Okay, she's so sweet. I'm going to go one more example, and that is an compound with, I'm going to do H2SO4, number 26. That's a polyatomic ion with 3 different elements in it. So you have hydrogen. So here you have hydrogen, sulfur, and oxygen. Again, sulfur has 4 different oxidation states. So what you have to do here is just go with your knowns, go with what you know, and figure out the unknown. And the unknown is sulfur. So we're going to actually divide this into 3 parts. Okay, we know that the sum of what we have at the top, we know that this has to equal 0, correct?
Correct.
Yes.
All right. And we know that oxygen's a 2 minus and hydrogen's 1 plus or plus 1. I don't care if you say, I generally try to go number then sign just to separate it from algebra class, but I go back and forth. All right, so what we're trying to find out is what sulfur's value is. So we go 2 times 4.
I can tell you what it is. I did it. Can I tell you?
Tell me.
It's 6.
Very
plus-
good.
Plus 6.
Yes. So oxygen is 8 minus. Hydrogen is 2 plus. So that means the sulfur's got to be a 6 plus
So small.
for this to balance out or neutralize. 6 divided by 1 is 6. Okay, how do we do?
We're doing amazing.
Excellent.
How do you know if it has more than one oxidation state?
I do.
General. Oof. If it's not in the rules, then if it's not covered in the rules, then it probably has more than one oxidation state.
And also, what does like an oxidation state mean?
It has to do with how many electrons it has in its valence.
Okay.
I simplified it. Basically, it's how it behaves in chemical reactions where you got to see in redox equations, oxidation and reduction, you have to keep up with the electrons to balance the equations. Most of your chemical equations we're going to get to balancing chemical equations, and balancing them for most of them, it's really easy. It's just simple math. But redox equations can have some really difficult numbers to work with. So if you in that case, you have to figure out what's going on with the electrons, because somebody's losing them and somebody's gaining them as you go through the chemical reaction. And if you can't figure out oxidation numbers, then you can't figure out who's losing and gaining electrons. Makes it very, very, unless you're a math whiz, a seriously math whiz, you're going to have trouble with it. So
I'm so good at math. So good at math.
I am happy for you.
Yeah.
This kind of stuff, I got to have these oxidation numbers to get there. So, all right.
You should ask them what they need help on. If they don't need help,
Yep.
And if they don't talk, that's on them, because then they're gonna fail their chemistry exam, and then that's gonna be on them, and then they're gonna.
All right.
and then we'll be the only smart ones.
Oh.
We already are the ones.
All right. Do you guys need any further, need any more examples?
No.
All right. I'll stop recording and stop presenting.